Namaskar. This is Professor S. Lal, Professor of Mathematics and Computing in the Department of Science and Technology in the Faculty of Education and Methodology, Jayoti Vidyapeeth-T. How are you? Fine. Yes. I hope you have completed all your previous sessions and you are also known to the fact that today we are going to discuss in your class. The students, as per your session, today we shall discuss about one variable probability distribution and two variable probability distribution. You know that there are some phenomena, there are some problems in your probability and random process, or in another word, you can say there are some circumstantial phenomena in our society or in the universe which are guided by more than one parameters. If you draw, for example, if you drop some, you can say, particles of water in a bottle, then not only the volume of the bottle changes with respect to time, but the depth, the height, the parameters of the entire, you can say, entire vessel also affected. So it is not always possible to discuss about all the probability problem with the help of a single variable. In some cases, there may be need of more than one variables. So please let us see the topic. I would like to share you this topic. You can see this is the topic. Generally, we know that how the probability of a function or a single variable is determined. It is not a matter of serious concern. But the two random variables, when we take the study of any probability, you can say based numerical problems, then it is a matter of our concern. Here you can go through that in many experiments the observations are expressible not as a single quantity, as I introduced you in the beginning of the topic, but as a family of quantities. For example, to record the height and weight of each person in a community, or the number of people and the total income in a family, we need two numbers, that x and y. The x and y denote two random variables based on probability model. The model we are going to take here is P of x1 less than x of I less than or equal to x2 is equal to fx x2 minus fx x1 is equal to limit of integration from x1 to x2 fx of function x dx, and you can take this nodal probability function. So in this way, what about the probability that the pair of random variables xy belong to an arbitrary region capital D? In other words, how does one estimate, for example, this? How this may be estimated? Where there are two variables in a different intervals, and we are discussing about their intersection. Toward this, we define the joint probability distribution x and y to be written as fx y xy is equal to probability of x like this. This may be taken as equation 1, where x and y are arbitrary real number. So I hope the students you have understand that how you can explain the two variables and two variables probability distribution function. And here are some properties when you are asked to write a note on one variable and two variable probability distribution function. Then it is also required, maybe asked to you, that count some properties and explain them. This is the first property. Just we have changed one variable as minus infinity, and then this has been taken as equation 2. Similarly, here is here is here is equation you can see property 2, and then here is properties 3. These are the pictorial representation of two-dimensional random variables along x-axis and y-axis. Joint probability density function we have already discussed, that is also based on two variables. So students, I hope that this concept will help you going through the details of the functions which are from probability and random process, but run and guided by two variables, because one variable is not sufficient to discuss all the phenomena that are going to be calculated or that are going to be discussed in your probability. Students, this session is powered by digital version 2.0 of Jayoti Vidyapeeth-T University Jaipur. In case of any query, feel free to write your comment in the inbox. I shall try to resolve your query from there. Thank you very much for joining this session, joining this lecture. Thanks once again.